Make sure we get that done. Today we want to talk about odd and even functions. And the odd functions would be a function of the example like y is equal to x to the third. Notice that it is to the third power, thus odd. But that's not the definition of odd. Two definitions for odd would be if the graph is symmetrical about the origin. If it has symmetry about the origin, then it's odd. Okay? So, let's go to what that means. The test is f of negative x produces negative f of x.
Isn't that the same equation, or is it different?
It is different. Notice how the negative moves from the inside to the outside. And that doesn't mean that we can just factor a negative out, nothing like that. Here's what it means. If I take an x value and plug it in, everybody agree I get out a positive value in that situation? This is saying that if I plug in a negative x value, okay, a negative x value, I get out the same y value, it just happens to be negative. So whatever's produced on this side for a positive is produced on that side for a negative. That's what that means, okay? So it has symmetry about the origin. Notice, again, that the degree is odd. It's easy to see. However, y equals sine of x, that's also an odd function, though you can't look at a degree and tell that. It's odd because it's symmetrical about the origin. Our even function that we're going to look at is y is equal to x squared. Even functions are symmetrical about the y-axis. Symmetrical about the y-axis. Notice that the power is also even in this situation, though not all even functions have an even power. For example, y equals cosine of x. And sine of x and cosine of x, those are ones we're going to look at second semester. That happens to be even as well. Okay? The test that we use to produce even and odd is this. F of negative x. So notice it's the same as the odd one. You just have to plug in a negative x. That's all you have to remember. But in this case, it produces just f of x. Notice in that situation, the negative disappeared. What that means is if you were to plug in an x value here, notice it produces a y value up there. If you would plug in a negative x value, notice it puts out the exact same y value, doesn't it? So it doesn't matter whether you plug in the positive or the negative, it produces the same output. That's what it means. Okay? So today we have two goals. Number one is to determine whether things are odd, even, or neither, and then be able to write rules for functions. This isn't too difficult. First, I'd like you to talk to the person next to you. What do you think? Do you think the first one is odd, even, or neither? Talk to your friend. Go. I heard a lot of people say odd. Can you say convincingly why you think it's odd? Yes.
Because the power is the third.
I see a 3 and I see a power of 1. Notice the 4 is even, but that's not the power. Let's see what happens. In order to determine, I always plug in a negative x. Please pay careful attention because too many of you made this mistake on the last test. We need to clean this up. Negative x quantity cubed minus 4 times negative x. First of all, get your parentheses around the negative. Okay? Now let's think about it. If you cube a negative, you produce a negative. So you get negative x cubed minus 4 times negative x. Is that going to be a positive 4x or a negative 4x? Positive 4x. Is that the same as what I started with? No, it's close. It's opposite. If I factored out a negative 1, would it then look the same?
Yes.
So watch what happens. We factor out the negative, and I get an x cubed minus 4x. Is that the same as what I started with?
Yes.
Yes. Now watch my careful piece of logic here. You guys will all fall into line. Notice x cubed minus 4x. Everybody agreed that's the same thing as f of x?
Yep.
So I'm going to write the negative sign, but instead of that, I'm going to write f of x. Notice what we just showed.
That's got to be an odd function.
That f of negative x is negative f of x.
It's gotta be odd. It's an odd function.
That's technically a proof.
Ooh.
Not all proofs are bad. Many of them are quite nice.
That one was quite nice.
You're going to love the next one. Do you think this one is odd, even, or neither? Make a guess. Talk to your person next to you. What do you think? Odd, even, or neither?
I feel like it's gotta be even.
Even
Just because of the square. How do you know?
Over there.
Thanks for clarifying.
Okay, so this is even, but the question is, what is the exponent for 10? It is not 1. It's the exponent of the variable. This is 10x to the 0 power. All of you know that anything to the 0 power is?
0. 1, sorry.
1. Therefore, 10 times 1 is just 10. 2 is even, and 0 is even. So both of them are, in fact, even. So we should see that this is even. I plug in the negative x. I get a negative quantity, negative x squared plus 10. Here is the mistake that many of you made on the last test. I want to point it out. We cannot do this. You said negative times a negative is a positive. That's not okay, folks. You must square this before you apply the negative. Okay? Order of operations, you must square this. So literally, there's 3 negatives here. I'll write out the 3 negatives so you can see them. We have a negative times negative x times negative x. Does everybody agree that that's that expanded?
Yep.
So there's 3 negatives. So is it going to be a positive x squared or a negative x squared? Negative x squared. And then we have the plus 10. Is that the same as what I started with?
Mm-hmm.
So what can I write instead of that? F of x. So we just showed that f of negative x is in fact f of x. So therefore it is even. The last one we said was odd. That's a proof. You just prove that it is even. It's very basic proof, but still proof. You have a different problem for this last one. I think I changed it. I think the problem that you have has a plus x on the end. Is that correct?
Yeah, that's right.
Yep, that's what I wanted. Do you think that that is odd, even, or neither? It is neither because you have both even and odd powers. Okay, so you've got both of them. It is not enough to come to the test and just tell me that this is neither. You need to show it. And the way you show it is you do f of negative x. And when we do, we get a negative x to the 4th with a minus negative x squared, and then plus a negative x. Is that going to produce positive x to the 4th or negative x to the 4th?
Positive x to the 4th.
Positive x to the 4th. Is that going to be a plus x squared or a minus x squared? Minus x squared. Again, the negatives don't cancel. You have 3 negatives here after you square it. So I've got minus x squared, and it'll be a minus x. Is that the same as what I started with? It's not. So I'll try factoring out a negative. And I get negative x to the 4th plus x squared plus x. That is not the same as what I started with either. So therefore, this is neither even nor is it odd. Even and odd functions have interesting properties that help us out in math as we move forward, especially second semester. We're going to see that play out. You good with that? Okay, so last thing we're going to do, I want you to draw these 6 onto your, oops, made a mistake there. I wonder what that used to be. All right, we're going to give this a shot. Here we go. There we go. I got these 6 out there for you. Put them on your sheet. And we'll finish off with this. That'll be the last of your unit. Had somebody first hour today who got behind a little bit in their homework. They're going over like their second homework assignment from this unit. They kind of forgot how to do it. That sometimes happens if we get behind. We went over a bunch of questions today that helped this individual, but I would encourage you guys, if you're in a situation you got behind something, stop in and see me. Tomorrow morning, link crew meeting for anybody who missed the previous 2. Choose one of the 3, so tomorrow morning at 7:45 a.m. Love to see you there. We're going to be in 8th grade classrooms on Friday, so I'm not available tomorrow morning for help, but I am available tomorrow after school for help and Friday morning for help. Got both those times available if you need me. Or if you have a study hall and you want to pop on in. Danica, you got a study hall?
Yeah.
What hour? 8th hour. I teach a math for college class, so if you ever want to come in and sit at the back of class and wait till I can answer questions, you can always do that. All right, so here we go. Everybody got them written down? So this is what the ACT tends to look like if they're asking problems about transformations. They don't necessarily give you the equation, they give you the graph and ask what is then the equation that you're supposed to produce. So for this one, I first noticed that this is a quadratic. It is x squared. But now I want to write it with the appropriate transformation. And I see that it's down 3 and it's upside down. So I'm going to write y equals, since it's upside down, I know it's going to be a negative x squared. And because it's shifted down 3, that's a vertical shift, so the minus 3 will be on the outside.
That makes sense. So do we have to say if it's odd or even?
Nope. That's all I want. Okay, for the next one, this looks like an x cubed situation. Okay? It looks like it also is flipped. Flipped vertically or flipped horizontally. Doesn't matter which one you choose. I'm going to choose the flip vertically. But I have y is equal to negative, and it's shifted to the right or left 4, excuse me. So I'm going to do an x plus 4 to the 3rd power. And that would be that rule. So you're trying to write the rule instead of graphing the function. Try number 3 on your own. Try number 3 on your own. All the brain research says that you do better when you try it than when I just do it on the board. Imagine that. You do better when you do more than when I do less.
The square root of x plus 4 is
Square root is my function. I've got a plus 4 on the inside, a plus 2 on the outside. What do you think?
Yes. Nice.
Good. You try number 4. Okay, here's the things I'm looking for. Number 1, the parent function should be a reciprocal function with x squared because they are adjacent to each other. Second of all, it's shifted to the right 2, so I need to see a minus 2. It's flipped upside down, I need to see a negative, and it's shifted up 1, so I need a plus 1. Any question on that? Okay, try 5 on your own. This is one where a lot of people had to look back at their notes to try to remember what is the parent function. And that's fine. Just remember when you get to the test, you will not have your notes on it. The parent function is a cubed root of x function. So I have the cubed root of x plus 3 because it's shifted to the left 3. It's shifted up 2, so I have a plus 2, and it is flipped upside down. That 6 is the toughest one. Not very many people got it right during first hour. Try number 6.
If the negative's on the outside, you just upside down.
Ben, did you put the negative on the inside here?
No.
Okay,
And where?
for this one.
Oh, we're talking about 6.
Okay, I'm sorry. I thought you were talking about 5. Never mind. 5 actually works to put on the inside or the outside. So.
It does?
It does.
But it doesn't flip vertically.
Anything odd.
It doesn't flip vertically.
So this one.
Oh,
turns
5.
out- 5, yep.
Sorry.
Yep, 5.
Yep, that makes sense.
If I get this right, I'm screaming.
Stretch.
You're getting it right.
Got this, Stretch.
Because if, okay, so any odd cubed or odd square root, it's 3 5s that it's gonna make this double shape. So it's always gonna be. so it's gonna
Okay,
be-
let's go bit by bit. Does everybody have a -2 on the end?
Yeah.
Okay, good. Everybody agree it shifted right 6?
Yep.
So I'm going to start with an x minus 6. And then there's a horizontal flip. So a negative applied to both of those. So in other words, the square root of 6 minus x minus 2. So you could write it like that. You could write it like that as well.
Oh, I can write it like that?
That's fine. My question is, how many of you wrote it like this? Please be honest so I can see, so I can help you out. How many wrote that? How many did that? Anybody read that?
No.
Nobody?
Because he doesn't go to the left.
Oh, I'm sorry. That's what, I'm sorry. If you apply the negative through, this should be a positive. So that's correct. This is incorrect if you have this. Okay? It must be that.
Wow.
It can't be that. Anybody write that?
That's what I had.
Okay.
So you either need the plus sign or the parentheses.
So I want to show you why this is wrong. The question came up. It was Cooper asked this one the last hour. Notice if I factor out the negative, I get an x plus 6. That tells me that it's shifted to the left, but it's not shifted to the left, is it? Finally, the last thing that I like to do with this is if I'm taking this test and I want to check my answer, I'm given this nice coordinate right here of 6, -2. And what that means is if I plug in 6, I should get an output of -2. What is 6 minus 6? Square root of 0 is? -2 is? -2. Watch what happens if you would have plugged in the -6 here, okay? If you plug in +6, you get -6 minus 6 is -12, don't you?
Yeah.
What's the square root of -12?
Imaginary.
Imaginary. So you can see that this point does not satisfy that equation right there. So you know that that's not correct. You can always plug in a coordinate to check. Okay, take out your homework. Got my buddy Ledger here. He's going to be working on this last part of the transformations worksheet that talks about even and odd functions. Okay, got 8 problems looking at that. And then on the next page, writing rules for functions. So you should be ready to finish this off completely. So you get a decent amount of work done in the next 10 minutes. Use your work time wisely. I will give you the entire day on Friday. You will also have Saturday and Sunday to work on your study guide, and then on Monday you have time as well. So we've got a lot of time coming up to be able to work. I'm here to answer questions.
I need a quick review on the ones that we did yesterday.
Good. Thank you for asking.
I don't know.
Let's start by describing the transformation first. So what's this going to do? So is that going to impact the x or the y? The x. If I would go right 2, what should I do to each of these values? Add 2. Yeah, when something says opposite of what you think, so just add 2 to the x values. You leave the y values alone,
Oh, I already
Because-
changed that.
only the x, because this doesn't do anything to the y's.
Okay. Okay, and then I just graphed it.
Yep. Now, you don't have to graph it, you can if you want to kind of see how it changed it.
I don't have to.
Nope.
Same thing for that, that's just.
Down two, so then you would change the, and you would subtract two from each one.
Okay.
A little bit better?
Yep.
Okay, good question.
So as long as this comes out the same as that.
Yep.
it's even.
Yep, because now, no, it is, so if you look at this, you factored out, this is a negative x quantity squared plus negative x. That's how I plug in the negative, see that? And if I square that, I get a positive x squared, then this is a minus x. Is that the same as what I have here? No. Factor out a negative, you get negative x squared plus x, but that's not the same. And we knew we needed to get even and yet an odd at the same time. See that?
Um,